Hi, I'm Michael Brunton-Spall. Remember to rate the session, etc. My pronouns are he, his, and him. I wrote a book. You probably don't care about the book. I write a weekly newsletter that covers ongoing stories. So, WannaCry, NotPetya. I cover like Russians and Chinese actors, but I also cover digital transformation and stuff like that. So you might be interested in doing that. It's completely free. I write it out of the goodness of my heart on Saturday mornings. And I'm going to talk about taking security seriously. And I was going to say why, and partly because I was asked to talk about that, but actually, the big reason why is because everybody seems to struggle with security. Like, this is not a thing that there are companies out there who have this solved, that actually only scrappy startups who haven't invested enough money find it hard to do security. Everybody finds it hard to do security. It doesn't really matter whether you're a global telecommunications company running in China, where it turns out you're being targeted by APT41, or whether you're the Georgian government, or in fact Georgian hosting firms who had their websites taken down, or whether you're running Indian nuclear power stations. You're finding cybersecurity hard. Indian nuclear power stations are some pretty complex IT and operational technology systems, and yet people are trying to get in there. You can be Twitter, you can be a startup. Who would have thought that a nation would be interested in targeting Twitter? But it looks like they were. Like the two employees at Twitter have been fired because they were acting on behalf of Saudi Arabia, and they're going to be charged with espionage for that. And it comes a bit closer to home. So do any of you know about the Swedish authority? The Director General had to stand down over this. So they had an IT security slip-up, I think, as it was described, which was a 70,000 krona fine because they took the driving license database and they handed it to IBM and said, please take care of this. And IBM outsourced it to a team in Czechoslovakia, in the Czech Republic. Sorry, very old name there. In the Czech Republic. And it contained secret data. It contained the driving license details of people in the military and people who are spies. And it contained their home addresses. And it contained the vehicle details of which vehicles they're allowed to drive. And because it had been sent to the Czech Republic and sent to a set of people who were not cleared, the Swedish government was incredibly upset over this whole thing. And then there was a big fine, but the Director General had to stand down. And, this is not a group of people who don't do anything with security. This is IBM we're talking about. They know what they're doing most of the time. They're doing the right thing. They're trying to follow the contract. We can talk about Proton VPN and NordVPN. One of the biggest VPN companies that produces both of those, and had execution vulnerabilities where you could alter the VPN config and just run code on people's computers, which was incredibly embarrassing. But they're a security firm. They should know what they're doing. You've got US Customs and Border Protection. So again, they had a breach where it turned out on the dark web there was a big data dump of some hard drives from a company called Perceptica, or Perceptics, who were the outsourced supplier. And their job was to build image recognition tools that the Customs and Border Protection were using to protect the border between Canada and the US. And on those hard drives that you could buy on the dark web was thousands of images of people who had crossed the border that they were using to train the AI with. Also was included some random MP3s that the person had decided to rip and listen to while they had personal documents, they had architecture documents, all kinds of things were in there. But, again, this is the US government. They have strict standards on what they're supposed to do, but an outsourced supplier just managed to get their data stolen and put up to the web. British Airways had the Magecart breach back earlier on this year, late last year, I think. Their estimated IT budget is somewhere in the region of £200 million a year, and yet they were able to be breached by a group called Magecart, who are literally just after stealing credit card details. That's all they want, is credit card details. We all find this stuff hard. Every company around the world is at risk of being breached. And I would say all companies have the chance they are likely to be breached in the near future. It's not a case of if you get breached. It's not a case of if you do the right stuff, you won't be breached. It doesn't matter whether you're Google, who had a recent breach, or Facebook, or Twitter, or IBM. Like, all of these companies have been breached. We will be breached in the future. And part of the problem is that computing is evolving. So the way we deal with computers has changed quite fundamentally over time, and it will continue to change. And I use a technique called Wardley mapping to kind of draw some of this out. But essentially, you can say, this is what it used to look like 20-odd years ago when I first started, which is I'd buy computers that looked a bit like products, literally buy racks of computers, put them in the data center, and we would have to manage those computers. In order to work out how I scale that, Nobody in the world was doing scaling 20 years ago, really. I was working at The Guardian, and we were learning how to scale web servers and deal with tens of thousands of people accessing things at once. And we had to custom build all of the software, all of the systems for scaling, all of that stuff. But then AWS came along. So I was one of the early adopters of AWS at The Guardian. We moved lots of stuff to it. And at first, we started saying, well, this is just like our computers in our data center, except the ability to spin them up and spin them down immediately changed the way that we interacted with them. They're no longer products that I go out and buy 10 of those servers. They become a commodity where I go, I want 100 of them. In fact, they become utility computing, where you can go, I want 100 now, but I'm going to have a tap, and I'm going to spin that up to 200 when there's a spike and spin it back down to 80. And the thing that happened was we get this emergent evolution of how things happen. But when a new thing comes along, when it moves over into commodity, you get a new practice of how you manage those things. So suddenly, DevOps had to come around, because if I'm talking about creating 80 new computers within 30 seconds of detecting an event that means I need more server compute, I need a different way of managing them. My old way, which was it took me 8 weeks for the computers to be delivered, and then Sharon would sit there manually typing out some scripts from a blue folder to bring the computer up and then physically install it into the rack. That process doesn't work. So what we now have is your old classical best architectural practice is commodified. Everybody does it. If you go to IBM or Deloitte or anybody and say, please run me a set of servers, they will say, I can do that. We have a standard process that we apply. And if you did that 10 years ago when you had AWS servers, they would look at it and say, oh, our process doesn't work for this. You're doing your process wrong. So you had to have custom-built processes. But the thing is, the same is true for security. Your security processes that worked when you had computers that had an 8-week lead time, when you had systems that were deployed once a year or once every 6 months, those processes are the best security processes that we have. But computing has evolved, and it's evolved significantly faster than our security processes have evolved. And that brings me on to breaches. We have breaches all of the time, but we have this mental model of what does it mean to be breached that is attached to this old world attitude of how security works. So when you actually look at things like, this is Verizon's 2018 data breaches report, and you look at this, 21% of the breaches in Verizon's data report were errors. Now, if I'd have asked you how many people think, what percentage of data breaches are due to error and what percentage are due to hackers, I think everybody would have said, well, it's hackers, it's China, it's Russia, it's those big scary people, they're the ones who get all the news. But in fact, 21% of breaches are caused by somebody putting the wrong name in the CC field of an email. And they send out a spreadsheet with everyone's finance details in, or they send the invoice to the wrong place. People make errors, they misconfigure things, they upload it to a S3 bucket that turns out to be public and they didn't realize. These are mistakes that people are making that are causing breaches. The other thing is that physical actions were present in 4% of breaches, and that's got a plus minus of 2%. So as low as 2% of breaches in the entire year were caused by somebody physically present in the building or near the server. But how many of us worry about encrypting the data at rest so that if somebody pulls the hard drive out of the computer, they don't get the data to run away with? Is it actually the right best practice anymore? Is it the thing that we're supposed to do? How many people are told you must not write your password down on a post-it that's sat on your monitor? And that means you have to have a password you can remember rather than a complex password, but you're worried about 2% of breaches as compared to all the people who attack you remotely. What about the fact that 56% of those breaches took months or longer to discover? That you were breached and did not know for 3 months or more. 32% were sent by phishing, and we'll come back to that. And 71% of breaches are financially motivated. We think it's children in their bedrooms who are bored and want to attack you. Anonymous will get me, Lulsec will get me, all these cool groups with fun names who apparently resurrect themselves every now and then. We're worried about those people, but in reality, most of the breaches are caused by people who just want money as quickly as they possibly can. And they need to work on how they do that. I could go on and on and on. I haven't talked about ransomware, and I don't have time to talk about ransomware. I could talk about extortion emails and fraud and criminal gangs and so forth. But I kind of want to make this a positive talk. I want to tell you about what we can do and what's happening. So I have got 4 areas that I think we need to think about when we're thinking about security. How do we as mostly non-security people. Is anyone here actually a security professional? Hands up if you're CISO or security professional. 1, 2. But the rest of us are probably CTOs, CEOs, CFOs, COOs, lead developers, architects. Our job is probably security tangential, but not actually directly security. So I think there are 4 areas we need to think about, and I'm going to go through those the next few minutes. The first is the one that we always think about, which is systems. We have lots and lots of IT systems that we have to manage. If we are technology people, we think about technology systems first, and they are important. For example, unpatched vulnerabilities are the biggest source of data breaches. The reason that lots of people lose their data is because there is a vulnerability in their application that there is a known patch for, that people have written an exploit for and then used it against the service because you haven't deployed the patch in time. For example, we all love to rip on Equifax. Equifax is a brilliant story of how not to deal with a breach. It is, in fact, a brilliant story of how not to deal with IT, or in fact, how not to run a company in many ways. But when Equifax knew that the thing was out there, the Equifax administrators were told to apply the patch. They sent an email out. I think the number was 630 something. They sent an email out to 600-odd systems administrators saying, please apply this patch. And most of them did not apply that patch. Many of them received so many emails that they literally just routed those emails to dev null, because they just received this constant flow of emails for systems they didn't care about. If you are told you need to patch struts and you are in charge of managing the VPN access points for the company, you start to think this security group isn't helping me. They don't know what I have. They aren't able to tell me what I've got. This advice isn't useful. They also wrote a tool that was supposed to scan the system, which actually turned out didn't tell them that any of the things were not patched. So there's some failures there. Windows BlueKeep. Has anyone heard of Windows BlueKeep? No, a couple people. It's got a funny name, which people tend to remember these things. So people remember WannaCry and they remember NotPetya and they remember BlueKeep and they remember all these things because they've got interesting names. BlueKeep is a vulnerability in the Microsoft Windows RDP, the remote desktop functionality, and it's quite a bad one. If you can connect to a computer remotely, you don't have to be authenticated, so you don't have to know a username and password. You just have to be able to connect, and you can take over the computer. It's quite hard to actually exploit. It turns out it's taken a lot longer for people to build exploits that you can just reuse than anyone thought they would, for a couple of technical reasons. There's a whole bunch of very dull reasons. But the patch came out, and very few people applied it. And in fact, the application process is just a linear line. And there were warnings. People wrote out these news stories saying, oh my God, there is now public exploits. The amount of exploitation is going to go crazy. We started seeing honeypot servers blue screening left, right, and center all over the internet as everyone was scanning and trying to find out, can I breach this service? And I can. But nobody bothered increasing the speed of patching. It didn't matter that there were news stories about it. People don't care. And I couldn't find a more recent statistic than this. This was the RAND study back in 2014 on Microsoft patches. And I haven't found a more recent version of this. But what they were showing was basically after Windows 7, I think it was, in 2010, the duration of patches, how long people took to build exploits, dropped rapidly until in 2013, over 95% of vulnerabilities had an exploit available within 30 days. So Microsoft would say, this vulnerability is a thing. We now know there's a RDP vulnerability or there's an SMBv3 vulnerability, and you need to patch it. And within 30 days, people had written and started sharing exploits that were publicly available for attackers to use. The average time to patch in the meantime is 69 days. So that means that, in general, you are going to have about 40 days of time in which your systems are completely vulnerable to a known issue, and there are exploits out there, but you haven't done anything about it. And this is not actually a very good metric because the average is weighted by the fact there are a bunch of companies, a bunch of organizations who can patch in under a day or two. If you look at the median, it's well over 100 days. And I get it. I do get it. So WannaCry was a 3-month-old vulnerability. The patch had come out 3 months before WannaCry started going around the internet and took out so many computer systems. The patch was available. People could have downloaded it and installed it 3 months prior. Even if you did quarterly patching, which is a terrible idea, but if you did quarterly patching, you should have been immune to WannaCry. But WannaCry spread so far because nobody patches. And I get it. Patching is hard. Patching is incredibly hard. But we have examples of this. Just like the previous speaker was saying, we have examples of people who are doing these things for the last 10 years who've been able to do it. GovUK, which is one of the services I worked on, we fixed Heartbleed within 2 hours because we had confidence that we could roll out a fix and we could deploy that using configuration management tools that was all automated and the deployments were easy to do. AWS fixed their AWS estate within an hour and built a tool to scan their customers' services and tell them, by the way, we've blocked this for you, but you're vulnerable, and if you haven't patched your stuff, you're going to have some real issues. I think the first thing we need to do, if you do nothing else, is sort the basics out and make it possible to patch your services. That is the most important technical thing we can do. You can buy shiny black boxes from various security companies that you put on your network and they will block the Chinese in some way, shape or form. Or you can buy a thing that will scan your services and make a very pretty dashboard. Or you can buy automated testing tools that will scan your code and look for vulnerabilities. And they're all good things. You should do those. But if you do that stuff and spend your money over there and don't sort out patching, it doesn't matter in the slightest, because you're still going to be vulnerable to the basics. We have to get the basics done first. They're really hard. They're not easy. It's not like I'm saying, oh, and by the way, if you just remember to shower before you go out, then everything will be fine. This is the equivalent of doctors learning they have to scrub their hands before they do surgery, not only before they do surgery, but every time they touch anything that's uncontaminated. And it took 20, 30 years for doctors to get that. They didn't believe the data. They didn't believe the science for a long time. But the basic hygiene is so important. From a tech perspective, I think that's the most important thing we can do. We have to focus on other things as well. So I think as well as systems, you need to think about people. And people is a huge problem and huge vulnerability in most of our organizations. It's not necessarily directly tech, but it's very connected with tech, which is it's connected with identity systems and the holy grail of a single sign-on. How many people here have a single sign-on system in their company? Keep your hands up if you have more than one single sign-on. Oh, quite a few people put your hands down. I'm quite surprised. Most organizations have multiple ones. In fact, you can now buy cloud access brokers, which will combine multiple of your single sign-on systems into a single sign-on system or something. I don't quite know. But identity systems is a thing for saying, how do we know who our people are? I work with a whole bunch of companies, and you'd think this is quite easy. Like, I have an Active Directory, it lists all my members of staff. And knowing who your staff are is a really important thing. Do you know who your members of staff are? Do you actually know which department they work for? Do you store that information in the directory? Do you ensure people only have access to the things that they should have access? Or are you vulnerable to people just browsing any directory they want to have a look at? But also, what do you do about contractors? Do you give them a device? Do you give them an identity? Or do you let them use their own identity? If it's an individual contractor you're having for just 30 days or 7 days, can you actually roll that identity out fast enough? Do you have to give them a whole bunch of stuff that you might not be able to get to the right place? But identifying people is incredibly critical because people and errors are one of the main reasons that we have data breaches. People make mistakes all the time, but we need to know who they are so that we can at least find that stuff. And we can find things like, did somebody leave and start sending emails back to themselves or doing stuff? What do you do about consultancies? If you bring in a whole set of people from IBM or whatever to manage your IT for you, do they use their IBM equipment and their IBM accounts and their IBM systems, or do they use your systems and your identity systems? Do you federate in some way, shape, or form? And what about when you go to other online systems? The world is becoming more complex in where we store our information, where we store our data. So I work with governments, and we had a big thing around something called Trello. So has everybody used Trello or heard of Trello at least? So Trello lets you track stories and so forth. And lots of government departments were putting data into Trello and leaving the boards open for anybody to look at, which if you're doing open source development is not a bad thing, and governments should be transparent about what they're doing. But when that data includes things like person X raised a support ticket and they would like their details removed from a system, it's quite bad to have that support ticket in the open as well. And people put all kinds of things in there, and this was discovered, and we had to go through and cut them all down. But what we discovered was people put all kinds of data into third-party systems. They put data up into GitHub, they put it into Trello, they put it into Jira. All these things are hosted in third-party locations, many of which do not support your core identity system. So you'll find people go, oh, well, yeah, I have a single sign-on identity system for logging into my laptop, but it doesn't work for the MacBooks that the development team have over there, so they have their own identity over there. And it also doesn't work when they sign into Trello, so they sign in with their own personal account for Trello. And when they leave, do we know what actually happens? Do they get kicked out of Trello as well as everything else? Would somebody create a Trello card saying, update the access key to be this new access key, and then somebody in systems would apply it? And generally, this is called joiners, movers, leavers, or JML. And the key thing around identity is saying, when somebody joins the organization, you should be able to create them an identity so they know what they're doing within minutes, if at all possible. One organization I worked with had a large number of temporary staff. So if somebody was sick, they needed to have at least 20 staff on the main desk to do stuff, and the temporary staff couldn't get accounts fast enough. The security team said it took 7 days to set up an account. That was how long it took. And the staff would often come in just for 1 day or 2 days. If somebody's got the flu, they're going to be off for 2 or 3 days and then come back. So we had a set of accounts that were temporary user 1, temporary user 2, temporary user 3, etc. And the password was temporary user 1, temporary user 2, temporary user 3. And this meant that everybody who came into the organization who had one of those temporary accounts realized very quickly that this was the pattern, and they could reuse it anytime they wanted in any external system from any location. We never rotated the passwords, and because we didn't know what those users would do, they basically had super user rights to every system because we didn't know what they were going to be doing on any given day. So we had a set of users who we had no track over. This stuff is really hard, but people is a vital thing to think about in your security systems. You also have to think about data. And data comes in 2 main areas. So you have to think about the core data of your systems and your services. That is, what is the data that drives your business? It's probably not technical. It's almost certainly managed in a spreadsheet somewhere by someone, because that's how many of our organizations actually work. They can't get a database from IT. It takes 9 months to run a project. So they run it in a spreadsheet with a bunch of macros they've written themselves, so they have macros enabled on their computer. But the key question is, what is the core data that actually drives your business? Is it the sales data? Is it information about what products you're going to launch next week and so forth? And then think about what data do attackers actually want? Because if your data is public data, then nobody really cares. When I worked for The Guardian, one of the things that we determined very quickly that we did not care about was people getting access to the stories that we had published, essentially, because we'd published them, we'd put them out in the world. It didn't matter if our content management system was exposed and that people could see the stories. We were a little worried about draft stories that hadn't gone out yet, in particular obituaries. We would write the obituaries for people before they died, and people get really funny about seeing their own obituary before they die. They get quite upset about that. So, but you do have to worry, what is it that people want? Because hackers will think that's hilarious. If they're going to attack a newspaper, the draft obituaries is the thing to go for. It's the interesting thing to target. So protect that differently to the rest of the other stuff. But the other thing is personal data. And personal data, certainly along Europe, luckily you're all European, not American, but in Europe, we're starting to recognize, or we have recognized, that personal data is incredibly powerful. And in fact, one analogy I've used is that you should treat personal data a bit like toxic waste. You should keep it encapsulated and let it touch as little as possible, because if it touches things, that thing gets covered in the personal data, and it's a really bad thing. But you need to ask yourself, do I actually need to collect and store it? It's been our default for about 30, 40 years to just go, yes, we'll collect email addresses, yes, we'll collect information about you, without any real idea about whether that's ever used or used appropriately. And GDPR has come along to really kind of strengthen that question about, do you actually need to collect it? And the question we should be asking ourselves for personal data in particular is not, should we collect it, but it's actually, can you defend the fact that you are storing it when you get breached? If you assume, like all those companies, that you will at someday be breached, and somebody goes, 100 million records were leaked from your business system, can you go, well, we had to keep that data because it was important to keep, and yes, we got breached and we've done everything we can to try and avoid it. Have you taken the right controls? Have you done stuff? But you need to be able to defend the fact you're storing it. If you just go, oh yeah, well, we were keeping people's names for fun, then GDPR is going to throw a really big fine at you. Whereas if you go, oh, that was necessary, it was sectioned off to one side, but there was a mistake in the deployment, you'll get a much smaller fine. And the information commissioners across Europe are all much happier with the idea that you are trying to protect the data. And finally, the one that is a big thing for me is process. It's saying, we've worried about protecting the systems and doing the basics. We've worried about protecting the people and starting to understand if we know who people are and what they do. We worry about the data. But process is kind of a dirty word to modern digital transformers. They hate it, like the process that slows us down, that's really painful and so forth. But actually, lots and lots of breaches come not from anything to do with the technology, but just exploiting the process. So phishing is a really big example. I said earlier, something like 57% of the breaches had a causal result of phishing, which is that somebody received an email and they clicked a link. And it looks a bit like this. Like, would you click that link? Well, actually, quite a lot of people would. In fact, most people's jobs require them to receive emails from their coworkers and strangers on a daily basis and click the links in the emails. It is a regular thing that you have to do. And attackers are getting smarter and smarter. So this one's not too bad. I mean, the email address it came from is not well hidden, and there's a few bits about how it renders and some other bits and pieces, but it's got a logo on it, and people are going to think, yeah, this probably comes from Netflix, and click the link, unless they don't have a Netflix account. This one is far better. So it says it comes from OneDrive, so I think it probably does come from OneDrive. It's got a document, but it's a secure document, so you have to click the link to see the document. I think this will get nearly 100% click-through rate in most modern organizations, unless you were an organization who specifically didn't use OneDrive or had processes for how you share files between teams. But most organizations don't. They're like, sharing is bad, we must take care of this stuff. And so security says, no, you must not click the link. But everybody has to click the link. It's a behavior that we require to do their jobs. The other one is CEO fraud. Does anybody know what CEO fraud is? Hands up if you heard CEO fraud. Actually, oh, excellent. Over half of you. So for those of you who haven't seen it before, and as we run over, CEO fraud is essentially when you get emails like this. So this actually is not the best one. It's the only one I could find. I don't have a good example of CEO fraud. But it's the case where you receive an email that tells you to carry out a business process that you would normally carry out, but the actual action is a negative action. So the common one is you get an email from your CEO who says, I'm just getting on a flight to go to America. I'm going to be offline for 13 hours, but I've forgotten to send the sales figures over to Marjorie. Marjorie's email is not working. Could you send it here? Another common one we've seen is the person phones up the IT help desk. I'm the CEO. I have to see an important thing. My VPN is not working. I need you to reset my username and password. Please set your password to this. And the IT desk will be like, it's the CEO. Of course I'm going to reset the password. You get things like people who contact you to say, please update my bank account details and send the money the other place. So I would call it invoice fraud rather than CEO fraud. But this is actually really common for finance organizations. And I worked with one organization who paid out tens of millions. And we went around the process of like, how do you defend against this? And they were like, well, we would check. We would never just update somebody's bank details. And we're like, well, how would you check? And they were like, well, if it had the same name at the top of the invoice, it's probably correct. And we're like, okay, well, here's how we can prove that. And they're like, oh, well, I'd phone them and check. What would you phone them? Well, the number on the bottom of the invoice. Well, that also came from the attacker. But finance teams, good finance teams, have processes in place. They require you to go through these processes that make sure that your organization is safe. They make sure that people don't send money because they're doing the wrong thing. And so we need to make sure that we understand that it's not always just a tech solution. There are a few tech things we can do here, but in reality, this is about do people follow the appropriate process? And following process, if it's a bad process, fix the process. But following the process is still often the right thing to do from a security perspective. So I kind of want to summarize, and I want to give you something to take away, something useful you could do. So I went around a bunch of people I know, and I tried to crowdsource a set of questions that would help you uncover this. So if I assume that you are not necessarily technical, or you're responsible for a set of projects, but you aren't a security expert, what can you do? And I came up with 5 questions. The first question, and some of these have got several sub-questions, but like the first question is it up to date? Am I vulnerable to flaw X? And you can say BlueKeep or WannaCry or whatever, like anything that's in the news. But you can say, is the services that I run or the project I'm running, will it be up to date? Will it be vulnerable to a given flaw? You should be able to know the answer to that. And it should be a thing you put in your contracts that if you have outsourced an IT service to somebody and you ask them that question, they should be able to answer you very quickly. They should not charge you. They should not take 3 months to determine whether you're vulnerable. You should be able to say, am I up to date? Do I know if all the patches have been applied? Because if we target at least the hard ones, we'll get there. The second thing is, what stuff have I got? Like, was everything actually updated? So is the system up to date? It's a big question. But also, how many computers are in that system? Was everything updated? Because again, Equifax's issue was they patched some stuff, but they missed a few things because some services weren't there. But if you'd asked this question, was everything updated? How do we know that? You'll drive those behaviors in the teams below you. A good question is, like, who actually works here anyway? Like, are there people wandering in and out of my building who do not have identity with my corporate governance system? Is there people who can just log on and log off? And I guarantee you will find in your organization a million workarounds for people who've just started, who need access to IT systems, who use somebody else's username and password for the first 2 weeks while they start there, who get given a temporary username and password that's just been passed around the team for decades and everybody just knows, who are able to just wander into the building. Because one of my friends has started a new contract last week, and he wandered up to the security and was like, I've started a contract, and they gave him a badge to wander around the building unescorted, which is nice because they didn't check or anything. So he went in and he discovered that if you take it back and you come back in the next morning and go, I'm really sorry, I forgot to give you back the day pass, they go, oh, that won't work today, have another one. And they gave him another one straight away, again, without checking. You find these things of, like, who works here is actually a really good question for trying to work out who should have access to these things. What data are we holding and why? Why do we have that data and what data are we holding? And finally, what about non-technical attacks? If you're talking to technical teams, ask them, but what about a non-technical attack? What about, don't worry about breaking encryption, but what happens if somebody sends you an email that tells you to do a thing? Is your customer service desk able to reset people's passwords? Do they know their process? So those things, hopefully those questions will help. That is all my things. Feel free to drop me an email or tweet me and sign up to the newsletter if you'd like more. Hopefully we've got some questions. Thank you.